So this is what I want to talk about this afternoon. We're going to go to the second part of our circuit analysis techniques. So in the first part, we discussed KCL. No, sorry. That was part of module one. No? In the first part, we discussed circuit simplification. No? We discussed resistors in series, resistors in parallel. Then we discussed delta Y to delta conversion. And then we also discussed sources in series, sources in parallel, voltage division, and current division. So that's the first set of techniques used for circuit analysis. And these techniques are used when you don't need to solve for all of the currents or all of the voltages in your circuit, no? When there are only few voltages or currents that you need to solve for. Okay. So now we're going to be analyzing circuits where there are plenty of unknowns in the circuit. Okay. I'm going to start with a description of terms used to describe circuits. So this is just terminology. And then we're going to go into circuit analysis using Kirchhoff's current law and Kirchhoff's voltage law. Okay, terms used to describe circuits. Okay, so these are just definitions. Let me start by defining a node. A node is a point where two or more elements connect. A point where two or more elements connect. So I've been using that term a lot of times already. So I think intuitively you already know what a node is. Now, an essential node, when you say a node is an essential node, this is where three or more elements connect. Why do we differentiate between a node and an essential node? No? Because if you have a point where only two elements connect, okay, so for example, I have here element 1 and element 2. No? So this is a point where only two elements connect. Okay. The current flowing into the node will be equal to the current flowing out of the node, and therefore there's really only one current flowing through both elements. No? So you don't have two, in this particular case, you don't have two unknown currents. You only have one unknown current if that current is not known at all. No? That's why we differentiate a node, an ordinary node, from an essential node. No? Okay. Now, what is a path? A path is a trace of adjoining elements with no elements included more than once. A trace of adjoining elements with no elements included more than once. Okay, later I'm going to give you an example showing all of these. Now, a branch is a path that connects two nodes. So anytime you have two nodes, okay, you have an element between these two nodes, that element will constitute a branch. And an essential branch is a path that connects two essential nodes without passing through an essential node. That's an essential branch. Okay. So, for example, again, let me draw an example. Okay. Let's say this is one node. This is another node. Okay. Okay. So this is non-essential because there are only two elements connected to it. Let's say this is essential. Let's say there are more than two elements connected here, and this is also essential. Okay. This is one branch. This is a branch. It connects two nodes. It connects this node with this node. This is another branch. Okay, that connects this node with this node. Okay, but this is one essential branch. This is not an essential branch because an essential branch connects two essential nodes without passing through any essential node. No? So this is not an essential branch. This is not an essential branch. These are just ordinary branches. But this whole thing, that is now an essential branch. Okay. Just a while. Okay, let's continue. A loop is a path whose last node is the same as the starting node. So again, I've been using the term loop already quite a number of times, particularly when we were discussing Kirchhoff's voltage law. Because Kirchhoff's voltage law is the sum of voltages around a closed path or around a loop. And finally, a mesh is a loop that does not enclose any other loops. Okay, so these are the terms that you're going to encounter: node, essential node, path, branch, essential branch, loop, and mesh. Now, I just want to say this about wires. Wires, what are wires? Wires are ideal conductors. So they are ideal conductors, meaning to say, if it's an ideal conductor, the resistance is equal to 0. Resistance is equal to 0 implies that charges do not feel any resistance or any impedance to its flow. Tuloy-tuloy lang yung daloy ng charge. Wala siyang nararamdaman na pumipigil sa kanya. Okay, stretching or compressing a wire in a circuit will not change the behavior of the circuit. In other words, if I have a wire, I can stretch it, I can deform it, I can compress it, and the behavior of the circuit will not change. That is the behavior in terms of the voltages and currents in the circuit. Okay, so let's try to illustrate this. Okay, I want you to answer, either shout out your answer or chat me your answers. How many nodes are there in this circuit? How many nodes? Anyone?
6 po ba?
Okay, 6. Somebody said 6. I'm getting some answers in the chat box. 7. Okay, I got an answer 9, pero mukhang hindi sigurado yung 9. Okay. Okay, how many nodes are there? Okay, these are your nodes. 1, 2, 3, 4, 5, 6, 7. There are 7 nodes. Okay, I think the one that answered 9 probably identified this as a separate node, no? And identify this as a separate node. Okay, remember what I said about wires. Wires can be compressed. In other words, I could have redrawn this as 1 point, no? This is really only, this is really only 1 node, no? And this is really only 1 node. Okay, because I could have redrawn that as a single point, no? Where I connect R5, I connect R7, and I connect I. I could have redrawn it that way. And this one, I could have redrawn it also that way. Okay. So there are 7 nodes, and I label them A, B, C, D, E, and F. Okay. How many essential nodes are there? Again, no? Can you shout out your answers or send them through the chat box? Okay, I have 4. Okay. Somebody said 2. Medyo nice try, ano? But unfortunately, it's not 2. Okay, the answer is 4. B, C, E, and G. No? If you take a look at these nodes, no, you're going to see that A is not an essential node because it only connects 2 elements together. D is not an essential node, and F is not an essential node, no? So dati we had seven nodes. 3 are not essential. So ang matitira is just 4 nodes, B, C, E, and G. No? Those are 4 nodes, no? Okay, ano yung significance ng well, let me get to that later, no? So how many branches are there? Okay. How many branches are there? Okay, each element in by itself is a branch. So if I count the number of elements in the circuit, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Those are all branches. So these are my branches. I specified my branches in terms of the element value. No? V1, V2, R1, R2, R3, R4, R5, R6, R7, and I. Those are all branches. So my question now is, how many essential branches are there? Okay, how many essential branches are there? Anyone? Or can I see your answers? Okay, medyo, I see only one correct answer so far. Remember, no, what is an essential branch? An essential branch is a branch that connects two essential nodes without containing any essential node. Connects two essential nodes without containing any essential node, no? Okay. So these are my essential nodes, C, B, E, and G. So what are my branches that connect two essential nodes? No, this is one branch. It connects C and B. Right. This is another branch. Okay. This is another branch. So that's 3. And then I have R5 is a branch because B and E are essential nodes. R6 is again a branch because E and G are essential nodes. This is a branch connecting B and G. And this is also another branch that connects B and G. In other words, I can have more than one branch connecting two essential nodes. No? R7 and I are two branches that connect two essential nodes. So that's 7 all in all. So V1, R1, R2, R3, V2, R4, R5, R6, R7, and I. Okay. Now, why do we want to differentiate essential branches from branches? Because when we're defining our unknowns, there's only one current flowing in an essential branch. In other words, I don't have to specify a different variable for the current flowing in B and the current flowing in R1. Iisa lang yan. There's only one current flowing in an essential branch. Only one current flows in an essential branch. Okay. Only one current flows in an essential branch. In other words, if I wanted to know how many branch currents there are in this particular circuit, that would be equal to the number of essential branches. Okay. So I have one current here, one current here, one current here, and so forth. No? Maybe a current there, another current there, and a current there. Okay. Sorry. Medyo misleading to, no? Okay, just one current here. So those are all the different currents. Okay, let's take up loops. Okay, give an example of 3 loops in a circuit. So what did we say a loop was? A loop was a path where the starting point and the ending point is the same, no? So a path is a trace of adjacent elements, And the starting with a trace of adjacent elements without going through the same element twice, no? And this, if the starting point and the ending point are the same, you call that a loop. So there are many loops in this particular circuit. I'm going to show you 3 loops. This is an example of a loop. We start at A, okay, we go to B, E, D, C, back to A. That is a loop. This is another example of a loop, okay, going this way. And this is another example of a loop. This whole thing is a loop. Okay. Can you tell me how many loops there are in this circuit? Madami, no? Madami. There are plenty of loops in this particular circuit. This is one loop. This is one loop. This one is one loop inside here. This is another loop inside here. Then I can take it 2 at a time. So this is one loop. Okay. I can take it 2 at a time this way. So this is one loop. Okay. This is another loop. And so forth. No? In fact, I counted before the class. I think there are 12 distinct loops in this particular circuit. No? So try counting how many loops there are in this particular circuit. I think there should be about 12. Okay, now this is a different question. Identify all the meshes. Okay, a mesh is a loop that does not contain any other loop. A mesh is a loop that does not contain any other loop. So how many meshes are there in this circuit? Yeah, I'm going to ask you what your thoughts are. Okay, someone, I think more or less you all got it, no? There are four meshes. So this is one mesh. This is another mesh. This is another mesh. And this is another mesh. No? So those are your 4 meshes. Okay, I read this in a book, no? If your circuit is planar, ang ibig sabihin ng planar circuit, you can draw it on a flat piece of paper without your wires crossing each other. So that's a planar circuit. If your circuit is planar, the number of meshes look like or is equal to the number of quote unquote window panes. So if you think about this as a window, these are the individual window panes. So ilan yung mesh mo? The number of window panes. Okay? So those are your meshes. Okay, so let's go to the meat of this lecture, circuit analysis using KCL and KVL. No? You will notice that you will have a lot of unknowns in a particular circuit. No? And if you have n unknowns in a circuit, let's say you have 10 unknowns in a circuit, we need 10 equations in 10 unknowns to be able to solve for all of these unknowns. Okay? So the question is, how many simultaneous equations must we solve for a particular circuit? Okay, first observation. No? The number of unknown currents in a circuit are equal to the number of essential branches whose currents are not known. I explained this earlier, no? Yung essential branch, importante yung essential branch kasi isa lang yung current na dumadaan sa essential branch, no? So the number of unknown currents in a circuit are equal to the number of essential branches kung hindi natin alam yung current dun sa essential branch na yon. So let's call that B, no? The number of essential branches whose currents are not known. So we need B independent equations to solve for the B unknown currents. Now, if I have a circuit that has n essential nodes, I can form only n minus 1 independent KCL equations. I leave it up to you to validate that, no? But if I have a circuit that has n essential nodes, I can form only n minus 1 independent KCL equations. I'll give you, remember yung two-node circuit natin? Remember we had a two-node circuit before? It looked this way. Okay, this is how it looked like, no? So I had V, R1, R2, R3. So this have two nodes. This circuit has two nodes. This is one node. Okay, so let's call this node 1. And then this is another node, no? This is node 2. Okay, if I assign currents to the different branches, no? Let's call this I, and let me call this I1. Let me call this I2. Let me call this I3. No? I3. Okay, sa node 1, if I apply KCL at node 1, what do I get? Ano? I1 plus I2 plus I3 minus I is equal to 0. If I apply KCL at node 2, I get the opposite, no? Minus I1 minus I2 minus I3 plus I is equal to 0. And note, this is the same. In other words, I have two nodes, but I only have one KCL equation. No? So in general, if I have n essential nodes, I can only form n minus 1 independent KCL equations. Okay? Because if I try to form n equations, I'm going to find that the last equation can be derived from the previous equations. For example, if I have 3 nodes, if I try to form 3 equations, I'm going to find out that the third equation can be derived from the first 2 equations. That's why they are not independent. No? So in algebra, you learned that, no? Na when you don't have a set of independent equations, you're going to get an infinite number of solutions. Okay, so going back to the problem, no? I have B unknowns. I have B unknowns. But I can only form n minus 1 KCL equations. Okay. So I need an additional B minus n minus 1 KVL equations to complete the number of equations needed. Ito yung balance na kailangan ko, B minus n minus 1 or B minus n plus 1. So let's consider itong example na pinakita ko kanina, no? So again, no? How many unknown branch currents are there, no? So let's assume, I'm going to assume, no, that known quantities are, okay, my sources V1, V2, my resistances R1, R2, R3, R4, R5, R6, R7, and I, which is also a source. So those are my known quantities. Sorry, I think I wrote this down. No? Yeah, okay. So assume the known quantities are the resistance values and the independent sources. So how many unknowns are there? No? There are 7 essential branches. So nakita na natin yan kanina. There are 7 essential branches. Okay. 6 of those branches have unknown currents. Kasi alam natin kung ano yung current flowing through I. No? Alam natin kung ano yung current dito. Okay. Therefore, dun sa 7 essential branches, yung 6, hindi natin alam kung ano yung mga currents na yun. So I need 6 simultaneous equations to solve for 6 currents. But I only have 4 essential nodes. I only have B, C, E, and G essential nodes. So if I have 4 essential nodes, I can only form 3 KCL equations because the 4th KCL equation can be derived from the other 3. So 6 unknowns, 3 KCL equation. Saan ko kukunin yung 3 equation pa na kailangan ko? So the 3 additional equations I can form by applying KVL to the available meshes. Yun yung magbubuo ng 6 equations ko. My 3 independent KCL equations, and then I have to take a look at the available meshes and then form KVL equations from my available meshes. Okay, so ito yung mga unknowns ko. The directions of current, you can assign that. No? If you don't know the direction of current, you can assign that. So these are, you might say these are assumed directions. No? But what I did, I followed the direction based on the polarity of the voltage source. So if this voltage source is supplying power, then my direction of current should be this way. No? Because normally a voltage source under normal circumstances supplies power. Ganun din dito. No? If this is supplying power, the direction of current should be from negative to positive. The rest of the currents, I don't know the direction, so I just assume. So these are all assumed directions of current. And I have 6 unknowns. So I label them I1, I2, I1, sorry. Okay, so I1, I2, no? Yung I3, hindi na, no? Because I2 and I3 are the same, no? Then I have I4, then I5, I6, and I7, no? So those are 6 unknowns. What are my 3 KCL equations? Okay. So where are my essential nodes? Okay. These are my essential nodes. B, C, D, and G. No? Those are my essential nodes. Okay, ang gagawin ko, dun sa 4 na essential node, mamimili ako ng isa. I'm going to make that my reference. Okay, so you make one essential node your reference. No? So let's say I make this my reference, itong G. Okay. So the 3 equations will be KCL here at B, at C, and at E. No? At B, C, and E. No? So this is my KCL for node B. This is my KCL for node B. No? So note, no? KCL for node B, remember the convention that I mentioned earlier. If it is moving away from the node, the usual convention is that it's positive. If it is entering the node, the usual convention is that it is negative. No? But it doesn't matter. No? If you apply the opposite convention, there's no problem with that. And then remember that this whole thing is node B. Itong buong to is node B. So what are my currents that are moving away from the node? I5 and I7. And my currents that are entering the node are I1 and I. No? So the sum of that, minus I1 plus I5 plus I7 minus I equal to 0. That's my KCL for node B. Okay, can I have a volunteer to tell me what the KCL is for node C? Very quickly. Can I call on someone? Let me call on Mr. Canyo. Ano yung KCL for node C?
Sir Cano po.
Cano, sorry. No?
Okay lang po. I4 is equal to I1 plus I2.
Okay, I4 is equal to I1 plus I2. No? That's good. Or I1 plus I2 minus I4 is equal to 0. No? Okay. And then for node D, can I call on Ces Santiago? Sorry. Node E, no? Node E, sorry. Node E.
For node E po,
Yes, oo.
bale ano po siya? I5 plus I2 is equal to I6 po.
Okay, I5 plus I2 is equal to I6, no? Or I minus I5 minus I2 plus I6 is equal to 0, no? So hindi ko kukunin yung KCL dito sa node G kasi yung KCL sa node G will not be independent of these three, no? In fact, if I eliminate from these three equations, no? If I try to eliminate what is it? I1 and I5, I'm going to get the KCL equation for node G. You can do that as an exercise. So I have three KCL equations, no? I have 6 unknowns. Okay. By the way, these are just notes. The current directions may be assumed. A negative computed value will indicate that the assumed direction is wrong. Okay, the KCL equation for node G can be derived from 1, 2, and 3 by eliminating I1, I2, and I5. That's what I mentioned earlier. No? Okay, so the 3 additional equations needed can be obtained by applying KVL to the meshes of the circuit. So this is mesh 1. That's mesh 1. What is my KVL equation for mesh 1? Can I ask Carl? Ano yung KVL equation ko for mesh 1? Let's say I go clockwise.
Clockwise, sir, that would be VI,
V1, yes.
V1.
Okay.
Then, for mesh 1 to, sir, no?
Mesh 1, oh.
Okay. V1 plus R1 plus R5 plus R3 plus R2 minus V1 pala. Minus V1, sir.
Okay. If you want minus V1, oh.
Okay na, sir. Yun. R1, R5, R3, R2, all pluses since drop sila. Tapos minus V1, rise.
You're equating voltage to resistance, no?
Yung yung voltage resistance, sir. Yes, sir. Voltage resistance.
No, yeah, okay. That's right, ano? So, ang magiging KVL equation mo is minus V1, okay, plus, I think you should say, no, para mas accurate, VR1 plus VR5 plus VR3 plus VR2, no? Is that what you intended to say?
Yes, sir.
Okay, is equal to 0, no? Is equal to 0. Tama yun, ano? Okay,
Yes,
but
sir.
what is VR1 using Ohm's law? What is VR1 using Ohm's law, no? Sige, Janica, ano yun? VR1 using Ohm's law.
I1 times R1.
Yeah, simply I1 times R1, ano? So this is just I1, R1. Itong VR5 is just I5 times R5. Itong VR3 is, okay, this is the tricky part. What is VR3? What is VR3? Can I ask Shaq Norio? Ano yung VR3?
I2 times R3 po.
Okay, here is the tricky part, ano? Ang VR3 is I2 times R3, no? VR3, if the current direction is this way, no? Okay, from left to right, then the polarity across VR3 should be plus minus, no? Plus minus. Pero dito, ina-assume nung sumagot earlier, sorry, no, I forgot who answered earlier, that the polarity across R3 is this way, no? Ina-assume na from plus to minus kasi positive ito. Okay? So if the polarity is Okay. Sorry. If the polarity is this way, because according to this equation, the polarity is this way, that is opposite the passive sign convention. Okay. And therefore, when you express your voltage, or when you express a relationship between voltage and current, you have to make it negative. No? So this is actually minus, this will end up being minus I2 times R3. Okay. Yun ang mangyayari dito. And this is also going to end up being minus I2 times R2. Okay, was that clear? Was that clear? Because the reason is we're going clockwise, no, and then this equation assumed that the polarity is plus, minus, plus, minus, plus, minus, plus, minus. Pero the actual polarity here is opposite, no? Is opposite. Therefore, this has to be negative, and this also has to be negative. So that's what you get for mesh 1. Any question with regard to that? Okay. So mesh 2, you're going to get something similar. No? Minus V2 plus I2 times R2 plus I2 times R3 plus I6 times R6. Well, this time, no, yung polarities agree with the directions of current, plus I4 times R4 is equal to 0. Okay, how many meshes do we have in this circuit? We have 4. No? But we only need 3 KVL equations. Okay. So ang tanong ko is this, no? Saan ko kukunin yung third KVL equation? Dito ko ba kukunin? Or dito? So is it going to be here, the first mesh, or here, the second mesh? Anyone? Can anyone render a guess? Doon ba sa una o doon sa pangalawa? Okay, somebody is saying the second. First, I guess you're all just guessing, ano? Okay, dito ko kukunin sa una. No? I'm going to get it dito sa mesh 3. Let me erase this first. No? Okay, I'm going to get it here sa mesh 3. Anyway, let me write the expression first. So that's minus I6 R6. Okay, why minus? Okay, why minus? Let's say I'm going around clockwise. Okay, so in going around clockwise, yung direction that I'm going here is counter to the direction of current. No? Counter to the direction of current. That's why this should be minus I6 R6 minus I5 times R5, but it is plus I7 R7. No? Because if I'm going clockwise, it is with the direction of I7. So that's equal to 0. Okay. Now I am sure that if I apply KVL on the meshes, I will get a set of independent KVL equations. I'm sure about that. Ano? Now KVL is not applied to mesh 4. Why do not I apply KVL to mesh 4? Kasi hindi ko alam kung ano yung voltage dito. No? There's going to be a certain voltage here, no? V of I. And I don't know what that is. And so if I apply KVL to mesh 4, I will be introducing a new unknown. And if I introduce a new unknown, I need an additional equation. So I don't want to do that. Okay? So that's why I don't apply KVL to mesh 4, because we do not have an expression for the voltage across the current source VI. No? For me to apply KVL here, dapat alam ko kung ano yung voltahe rito. Okay? So those are the KVL equations that I will apply. No? So that now totals 6 equations. No? So these 3 equations plus these three equations, itong tatlo. Again, itong tatlo. 6 equations, 6 unknowns. So the problem reduces now to a math problem. Math na lang, no, ang kalaban natin. Hindi na ito EE problem. Okay. Are there any questions? Are there any questions so far? Any questions? Okay. Anyway, I just wanted to say something extra, no. Kasi binanggit ko rito, no, sa number 1 that applying KVL on the meshes will ensure a set of independent KVL equations, no? Because actually, when you combine mesh equations, you get a loop equation. No? For example, what will happen if I combine the equation for mesh 1 and the equation for mesh 2? No? What will happen if I combine these two? If I combine these two, I can eliminate I2. No? I2. Because I2 is common to both equation 1 and equation 2. You notice, no? I have I2 here. I also have I2 here. So I can eliminate I2. So if I combine this equation with this equation, I am going to get the mesh equation for this bigger loop. Yun ang mangyayari, no? Pag kinonbine ko yung equation 4 at saka equation 5, ang lalabas is my mesh, my KVL equation for this bigger loop. May eliminate ko tong I2. And those 3 KVL equations are not independent, no? Because the third equation can be derived from the first and the second equation. They are not independent. That's why if you want a set of independent equations, independent KVL equations, para sigurado, you just apply it to the meshes. Apply nyo sa meshes. No? Because if you choose just an arbitrary set of loops, you might encounter the problem na hindi pala independent yung equation na yun. So I hope you understand what I'm trying to say. Okay. So let's take an example. So for the circuit shown, solve for the values of I1, I2, I3, I4, I5, and I6. So I have 6 unknowns. I need to form 6 equations involving these unknowns. I have 4 essential nodes, A, B, C, and D. So these are my essential nodes. Okay. Yung isa dun sa essential node na yon, okay, one of those essential nodes, I'm going to assign as my reference. So let's say I make D my reference. No? Let's say I make this my reference. Okay. So from the 4 essential nodes, we form 3 KCL equations with D as reference. By the way, no, sometimes we designate the reference by showing the ground sign. Later on, I'll tell you why. No, I'll tell you why. So from the 4 essential nodes, we can form 3 KCL equations. So for A, straightforward, no? Minus 8 kasi papasok, plus I1 kasi palabas, plus I2 dahil palabas. And then here I have minus 4ix. Dito, I have minus 4ix from left to right. That's equal to 0. Okay. Then for node B, I have I2. Okay, this is node B. No, I have I2. Minus I2 plus I3 plus Ix is equal to 0. Then for node C, I have minus I3 plus I4 plus I5 minus 4ix is equal to 0. So those are my 3 KCL equations. Okay. Now, the remaining three equations can be formed by applying KVL to the meshes. No? To the meshes. I have 6 unknowns. I1, I2, I3. Sorry, I1, I2, IX, I3. 1, 2, 3, 4, 5. Ano ba unknowns ko? Yeah, I1, I2, I3, IX, I4, I5, I. Okay. I have 6 unknowns. So, tatlo na yan. So now I apply KVL to the meshes. Okay. The meshes that I'm going to use are this mesh, mesh 1, mesh 2, and mesh 3. The reason why I don't want to use this mesh is because I don't know the voltage across this current source. And I also don't want to use this mesh because I don't know the voltage across this controlled current source. So again, if I apply KVL to the meshes, okay, that's minus 10 I1 plus 20 I2 plus 30 IX is equal to 0. Mesh 2, and you can just follow, 40 I3, 60 I4 minus 30 IX is equal to 0. Minus 30 kasi we're going clockwise, and that is against the direction of I's of X. No? And then mesh 3, okay, so mesh 3 here, minus 60 I4 plus 50 I5 plus 10, okay, plus 10 because that's plus to minus, that's equal to 0. No? Okay, actually may kulang pa rito, no, sorry. 1, 2, 3, 4, 5, 6. Walang kulang, no? Okay. So I have 6 equations. If I solve that simultaneously, these are the answers that I should get, no? Your calculator, I think, can solve up to ilan ba? 4 equations in 4 unknowns. I'm not sure, ano? Depende siguro sa calculator nyo. So, for example, if you have yung Casio calculator, the common Casio calculator, I think this can solve 4 or 5 equations in 5 unknowns, no? Pero hindi na niya kaya pag 6 equations in 6 unknowns, no? But then there are other tools that you can get online to solve for 6 equations in 6 unknowns. Otherwise, you're going to have to learn to use the techniques you used in, or the techniques you learned in algebra. So solve nyo yung 6 equations, and this is what you should get. Are there any questions? Okay. So I'm going to stop there. No? Like I said, I have a meeting, so I have to cut this short. I would have wanted to discuss more examples, but you can take a look at the recommended text for more examples. But we're going to continue next time. Okay. Ang problema nito is medyo hassle nga, no? Because like I said, your calculator can only handle, if I'm not mistaken, matignan nga, no? Yeah, my calculator can only handle up to 4 unknowns, no? Hanggang 4 unknowns lang, no? Nobody wants to solve simultaneous equations with too many unknowns, no? So what we're going to study next time is paano natin babawasan yung number of simultaneous equations that we have to solve. Okay? So in this case 6, can we even reduce it further? And that is the point of the node voltage method. So I'm going to introduce to you next week, this is module 3, the node voltage method, and then we're going to take up special cases of the node voltage method. No? We're going to go through this method slowly because this method is going to be the foundation of most of your circuit analysis in the future. In other words, hindi nyo maiiwanan tong node voltage method na to, no? Throughout your entire EE career, you're going to encounter the need to use the known voltage method time and time again. So we're going to take it slowly next meeting. Are there any questions with regard to what I presented today? Okay, so take a look at the notes. Try to assimilate, take a look at the notes. May question. May strict direction po ba yung loop sa KVL? No. You can choose, no? Pwedeng clockwise, pwedeng counterclockwise. Nasa sa inyo 'yon, how you want to traverse it. Okay? Importante lang when you traverse it a particular direction, you make sure that you're taking note of the polarity of the voltage as you traverse the loop, As you traverse the loop. That's all that's important. Any other question? Okay, so if there are none, I'm going to have to close the session. So sorry, I won't be able to entertain more questions. Thank you.
Thank you po, sir.
Thank you po.
Thank you po, sir.
Welcome.
Thank you
Thank
po.
you po.